Hello everyone. Recently I got a question of how we can calculate true length or 3D length in QGIS. So in this video I wanted to go through that process. You're going to need a digital elevation model for this, so we're going to pull one from our rasters geopackage project files, and I'm just going to grab this DTM1 and drag and drop it into the project. I'm going to right click on this and go to layer CRS and choose to set the CRS of the project from that of the layer. Then we need to also create a new line layer. But before I do that, just so we can visualize this digital terrain model, I want to create a 3D map from it. And so you can go to the view menu, and then up above there is this 3D map views, and you can choose to create a new 3D map view. This window will pop up and you can just expand it, and I'm actually going to dock it at the bottom of QGIS just by dragging it there and releasing. Now you're not going to see anything here in 3D until you go to the configuration and then go to configure, and here under terrain set the type from flat terrain to DEM, and then under elevation select your DEM layer. You can adjust the vertical scale if you want, but I'm gonna leave it at default for a more realistic view. And then I'll click on apply and OK, and now you can see the 3D representation of this DEM. If you want to orbit around, just hold the middle mouse button and then just drag your cursor around. Now I'm going to choose some kind of a more pronounced area of elevation on this DM, like this one here, to create our line that we can measure. So we are going to come here to the new shapefile layer button and create a new layer. I'm just going to call this line, and the geometry will be set to line string, and the EPSG will be the same as that of the project, and I'll press OK. Now we can select this line layer and click on the toggle editing button, and then come up here to the add line feature, and let's just draw a line in this corner that crosses over this gully here. So I'm gonna start from the corner here and then just cross it like that, and then right click and press OK. And now we can see our line in both views, so you can see it also on the 3D view. I'm just going to quickly change the color to make it more visible. So we will select the layer, go here under the open layer styling panel, or you can right click and go to properties and then go to symbology. It's the same thing, and I'll change the color to something more visible, like let's say a cyan color, and I'll change the width to maybe 1 and click on apply and OK, and now we can see the line more clearly. Now this 3D map view actually has a measure tool here, so if you go to the measurement line tool and just select that, you can try to measure this line directly in the view just by making 2 points, and it will say total 3D distance is 1570 in this case, and total horizontal distance is 1561, but this is not correct, and we need to do this process differently in order to get the correct or true length of this line, factoring all of the elevation changes. If you want to get a truer representation of the actual distance of this line, you need to basically create more sampling points, which is again something we will do later, but in a more automatic fashion. So if you use the measurement tool here, all you have to do is basically to click along the length of the line and create many sample points, and now you can see the distance is quite a lot different. Now the issue with this approach is it's good for quick measurements, but it's not very accurate because it relies on your basically manual clicking, and that can have errors. So we are going to do this differently. So I'm going to exit out of this and toggle out of the editing for this layer and save the changes. Now the first thing that we need to do is to create more vertices along the length of this line, because the vertices are like sampling points. And currently this line has only 2 vertices, and that's how the distance is measured. So we have a vertex or a point here at the beginning and another one at the end of the line, and that's how it calculates the length. So we need to create more vertices, basically more sampling points that we can then measure the distance between and sum it all together to give us the true length. And those vertices also need to be kind of forced to stick to the terrain. So we need to embed them with the elevation values of the underlying digital terrain model, so that when we measure the distance in between the vertices, it factors in that they are placed at different elevations. So the first thing we need to do is to split the line into different segments, maybe something kind of at equal distance. So we can choose, for example, a 10 meter or 20 meter distance. Of course, the tighter the distance is, the more precise the measurement will be, but also the heavier the line object will become. And if you have a very tight distance between the points, you may even bog down QGIS and might crash. So I'm just going to use like a 20 meter distance to do this. So the first thing we need to do now is to go to the bottom left corner in the search field and just type split line. And we are looking for this algorithm called split lines by maximum length. So double click on that. Make sure that you have actually selected the line layer first, because this is how the algorithm knows what exactly you want to split. And we're going to set the maximum line length to 20. And then just click on modify all features, and then we can close. And now you can see it created these 20 meter segments. Of course, at the end of the line, it's not going to be 20 meters because it cannot force the line to become longer. So for the most part, it's a 20 meter segment in, intervals. Then we can exit out of the editing and save the changes. So now the line has all these segments created. The next thing we need to do is to force each of the points of those segments to stick to the underlying digital terrain model. So we are going to use a command called drape. So again, go to the bottom left corner and type drape. And this is the one we're looking for, drape set z value from raster. Double click on that, and for input we're going to have our line layer, and for raster layer we're going to have our digital terrain model. Everything else here can stay the same, so you just click on run, and the processing is now finished, so we can close out of this. So a new layer called draped was created, and you can see it also in our viewports. If you actually mouse over these two layers, you can see that they're of a different type. The line layer is a multi-line string, and before we actually created those segments, it was just a line string. It was not created of multiple segments, whereas when we created the segments, it became a multi-line string geometry. Whereas the draped line is a multi-line string Z type of geometry. So it has an elevation embedded into the vertices of each of those segments. And so this is the fundamental difference between these two. So this is basically a 3D object right now, whereas this line layer is a 2D object. So now we can grab this draped object and calculate the total length of all of these segments. And we're going to do this using just the basic show statistical summary. So this is this button right here. Just click on that and this new panel will appear. What you have to do is to just drag the layer that you want to make a calculation for, or just select it here from the drop-down menu. Now let's first calculate the total length of the line layer. So you can either drag it or just select it, and here in the empty field you can type $length and just press enter, and this will give us the sum total of the length of that line. So this is measuring the distance between the two vertices that original line had. Now let's do the same thing for the draped. So we're going to measure length, and you can see the sum total is the same because the length command measures the 2D distance. So it takes the beginning and ending of the line and just measures the distance between those 2 points. So we need to use a different command for the drape layer. So let's come here and click on this button to the right hand side of this field, and we're going to type a new command. So this is a little bit of a long command, so just follow along and copy and paste it. I'm also going to place it in the description under this video, so you can just copy and paste it in the future. And so it begins like this: sqrt. We open a bracket and then type $length to plus z_max. Then we open a bracket, $geometry, close the bracket, minus z_minus, open bracket, $geometry, close the bracket again, and then 2, and we close the bracket. So with that, we're going to press OK. Again, I'm going to paste this command in the description of the video. And now you can see the sum total of our line is very different. So this is the actual true length or 3D length of that line. Again, this is based on the 20-meter segments that we created. If you create tighter segments, let's say 1 meter, then there will be a difference in this final calculation. Probably not a big difference, but there will be some, because you're basically using a higher quality sample, so to speak. And so this is how you calculate 3D length. Thank you very much for watching, and we'll see you in the next video.